because of our condition up here, if grape's null, we just go straight to random move. So we'll never actually bump in here. So we can't test this quite yet. But that's okay. We can, however, if we want to, we could feed in, two different integers into getMove and find out what comes out, right? So get how far Oscar is to the grape. So this is where we want the absolute values. Let's see. Yeah, well, just to be quicker. All right, so int absolute, I'm just going to say RD equals 0. CD equals 0. So I'm just, even though this isn't the only way to do it, I'm just going to create two new variables real quick. Absolute value of the row distance, absolute value column distance, because I'm going to have a condition to determine what these are, right? Because if you remember from math, so if row dist is less than 0, right, meaning it's negative, then actually we don't need to do that, do we? Okay. Haha. Yeah, we can do that. And you're probably going, what? But we can actually change these because we cannot break these. If you remember from class where I said that when you pass in these values, right, when row dist and call dist are passed into getMove, the value that's here, right, if it's 3 or whatever, it gets copied into this new variable that's held by getMove. So no matter what we do to these values don't change. Not that I think we'll ever need them again, but we can't break them. Okay, so if this makes sense, we're saying that if the row distance is less than 0, so it's a negative number, then the row distance is going to be reassigned its current value times -1. So if it was negative, then it's going to turn it positive. If it was already positive, we didn't do anything to it. All right, so we should, after this, have the absolute value of those numbers. And we have to do it for each row dist and call dist. There we go. Okay. So these are the actual distant absolute values here. And now from our move in the direction that makes Oxford closest. So we had some, right, really like all this stuff. Okay. And then again, it's going to be kind of ugly, but and all you have to do is hit tab once and it's automatically going to take you to the same indentation that you had. So that's reasonably quick. And then just going to comment these guys out real fast. Okay. Whoops, one more. There we go. Okay, so this whole thing, we'll be moving him. All right, so we've already computed these absolute values, or we've transformed row dist and call dist into their absolute values, which is cool. Oh, you know what? Actually, we can't change them because we wanted the saved difference. Looky there. See, I already broke something. And I'm getting even lazier. Okay. Now, we can just replace those. And see. There we go. All right, so now we still have the original, so we know if it was positive or negative. And now we have copies, or we transform them to get their absolute values. Okay, so we have that. Now here we go. If the absolute value, whoa, okay, that's really long there. We can just kind of bring that down. Okay, so we want to know if ABSR, if the absolute value in the difference in row is greater, okay, is greater than ABSRC, okay, then we're changing rows. Actually, let's do this. Oops, okay, so, all right, we need two sets here. So we're going to copy that out, put that there, so we're changing rows. Now, if that isn't true, we come down here. Oops, wait a minute. What? Okay, so we're changing rows here. Well, that's weird. Maybe I missed something in the other place. We are changing columns. Okay, and then if the difference is positive, okay, so we have another condition, if. Now in this case, we're using dist is positive, so greater than 0. Whoops. Gosh, darn it. There we go. Okay, so if the difference in row is positive, exit that, put that here, so tab that over, and then else, exit. There we go. We don't really need else. I mean, I think we can figure that much out. Okay. And then we come down here, and then we have a very similar. In fact, we'll just copy this, come down here, do that, call dist, call EAST. Okay. Okay, so that should handle all that. So now we just kind of need to fill these things in. Okay, so it's positive. Oscar wants to move to a lower row number, which is north. So ultimately we know what that is. So move equals north. And exit. There we go. And it's fine, we move a little space. Move equals south. Move equals west. Move equals east. Short that up a little bit. Give that space there. Okay. Okay, so compile, everything compiles. And so even though we've changed a little bit of this stuff around, basically this is all defined by the pseudocode that we had here. So it's going to take in two integers, figure stuff out, figure which way we're going to go, and return that move. So we can test this. So we can create Oscar, Create a new one, same name. So now we can choose get move that takes the integers. And so in this case, we'll assume that our guy is going to be at 1, 1, and we're going to give it 2, 1, right? So we're going to try to, we should go south to G3, right? So 1, 1, and 2, 1. So, actually, let me think about that for a second. We had the row. Oh, never mind. Okay, close. We needed. Okay, so we have. Yeah, we need the output of this. Okay, so row is going to be -1, right? Because 1 minus 2 is -1, and then the column is the same. So -1, 0 is what we're giving up. Okay. So -1 and 0. Okay, we would go south. So barring that our other logic doesn't work very well, then it looks like, at first glance, that this move in the direction that we want to is probably going to work. Okay, so the only thing left then is finding a grape on the board. We can shore that up a little bit. Okay. Excuse me. All right. Okay. So we want to find a grape on the board. Let's go back over to our pseudocode, and we will snag all of this bad boy. Come in here, do the ugly thing, and then it's going to take a minute to get everything over here. So there's a little bit of an advantage to writing some of your pseudocode inside of BlueJ, just so that you don't have to copy stuff over. The advantage to doing it somewhere else, like, I don't know, Word or Notepad or someplace else, is, it might be a little bit handier for tabbing and numbering and moving stuff around without having to worry about whether or not something's going to compile. But at any rate, so this is our pseudocode for finding the grape. We'll break these into separate lines just so that you can see it. I'm not too worried about the end of that because I'm just asserting that there's more than one way to solve that problem. So now when it comes to writing some of this stuff, it may not have been super obvious so far, but I've been trying to write and compile my code from sort of a outside-in kind of perspective. So when I was building different chunks of it, if you have something like a condition, right, like if grape is null or it's anything else, it's good to be able to write that, right? So all of this stuff I sort of threw together all at once because I'm familiar with writing this stuff, and it's not that daunting for me. But the idea is that even if I didn't know right now what to put on the inside, or I didn't want to mess with the inside just yet, I could write this skeleton. I could write all these conditions, and then I can compile that. So if nothing else, that in case I had some kind of error somewhere in here that caused my code to not compile, I would know at the point that I encountered that this set of conditions itself is fine, and there's nothing wrong there. It's just the problem would be right here. So we're going to encounter sort of a similar thing here. Well, and we did it with the methods too. Like, you build a basic skeleton of the method, make sure that that's okay, and then build some of the guts. So it's important there, and it's going to be especially important now if I can actually find where I'm trying to write stuff. Here we go. So now that we're going to be iterating over the board, if you remember from class, the board is a two-dimensional array of characters. So we're going to have to loop twice. The first loop is going to be over the rows of the board. Each row of the board is a column of the board. So at the level of each row, it's not very useful yet, right? It's a whole chunk of column, and it doesn't do as much good yet. So we have to iterate then over each column. So because this starts to get a little hairy, we want to build it out in a very careful, outside-in sort of fashion. Okay, so if you remember, or if you don't, that's fine too. Okay, so now right here, Java isn't going to let us compile this without anything in it. It does require stuff inside of there, but we're going to say, so we have to have some variable that's going to control our loop. In this case, it's going to be an integer, and just because this maps contextually to rows on the game board, we're just going to call it a row, and our lowest possible index is 0, so int row equals 0, and then our rows need to be less than. Now, if you don't remember this, here we go, board dot length. So what that is, so board is referring to our array of arrays of characters, and so this first array, or the outermost array, is our rows. So the length of board is the number of rows, right? So by keeping this index into our rows less than its length, so like if there's 20 things in here, that means we really only want to go up to 19 because we started at 0. So, and then at the end, we have to make our rows go up. So there's a little more concise syntax, but for people who aren't as comfortable with it, we'll just say row equals row plus 1. Okay, so now I can compile this. And this would go over each row, and that's it. So it would get each row out of the table and then do pretty much nothing with it, which for right now is perfectly fine. So now what we can do is we can say for each row, blah, 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 blah. So there's all this stuff now that we can cut from there, and we can put it inside of here, because now it's going to be happening inside of this loop. Now we've broken up our purple, and that's okay. We'll get over it. Okay, there we go. Because all of this stuff happens inside of this iteration over the rows, right? Because our point is finding a grape on the board. So if we're not inside the board, yeah, we're not going to find any grapes. So this is going to move over all of our rows. We'll compile it, just sanity check, everything still works. So for each row, now we want to iterate over the columns inside the board. So once again, we're going to have a for loop. Int call equals 0, call less than board. Now this time, so board.length, even though our board is set up as a 20 by 20, what I would recommend is, rather than focusing on the length of the board and using that, I would use the length of the first element. in the board, right? Because L-E-N-G-T-H, there we go. Because the first element in a row, or rather, the first, yeah, that's right. The first element in a row is in fact the column. So anyway, just use this syntax. Board bracket 0 dot length. So this will get us the length of each column rather than the length of each row. Because if our board were lopsided, right, and it was longer than it was tall or taller than it was long, if we only used board.length, at some point we're going to mess up, and it's gonna break things. So, and then call equals call plus 1. Now we're starting to kind of get far out there on the right hand side. We'll try to keep it in. So we'll X that. We'll put it up here. So now all this stuff can go inside here. Because this is stuff, or at least so far, this is all stuff that we want to do while we're looking. So for each row, we'll do this in the board. Iterate of the columns for each column in each row. So I'm adding just some specificity here just to say that, so now we're talking about the column in each row. We can't forget that we're inside of a row when we're talking about this. So get the character in that square of the board. So now that we have both the row and the column, we can get individual pieces of information out of the board. So what kind of thing is that? It's just the character. And we'll call it a chit. That's like a game piece, and a lot of games are called chits. So so now here we're going to use row call. So this is going to get us the individual character that was in a square of the board. So once we have that, then we want to find out if the character is a G. So if chit equals G, we'll just put that. Whoops. Yeah, that's fine. That's also another way that you can do it. Kind of keep it in line there, because this is in line. As long as it comes after your code, you can just leave it there. So it was not what I was intending to do, but it works, right? So if chit is G, we're definitely going to want to do all this stuff, I think. Let's paste it in there. Tab stuff over. Okay. Because if something is not a grape, Oscar doesn't care if something is not a grape, so we're not going to do anything. Right? We're only going to respond to the contents being a grape. That's it. All right. And we'll just be a little more concise here. Say the current row and column. Now, this is a good time to point out that when we have pieces of information that we are deriving, like inside of a loop, that we want to have after that loop is done, we have to create them before the loop. If we create them somewhere inside of the loop, then when the loop is done, they go away. Piff. Same thing with our method, right? So we created this coordinates core up here. it only exists inside of find grape. That's it. Outside of there, this variable does not exist. So it is local to this method, and inside of this outermost for loop, row exists here, and it exists everywhere inside of it. So we can see it here, we can see it here, we can see it here, but as soon as we jump out back here, well, now row doesn't exist anymore. We can't talk about it. Same thing with column. It exists inside this interior loop, but after, so if we tried to put, col equals 0 down here, we can't get to that. In fact, it thinks we were trying to do something else. So, which means because we're not seeing this one anymore. It's dead and gone. So anyway, if we want to save the row and the column for the grape that we've gotten, then fortunately, we've already created the thing that we were going to put that information into, right? That's the coordinate. So we're going to say core equals, and if you don't remember, we can scroll down to the bottom. So our constructor for coordinates is coordinates, and we give it the row, and then we give it the column. And that's pretty much it. Let's say new coordinates. So, and then we have to give it row and then col. So that should compile. Boom. So now that we have stuffed the row and the column into a new coordinates, this guy is populated with information, and when we return it, it will not be null. Okay, and then Oscar pointedly doesn't want to look at anything else, so now, okay, so if we wanted to stop, well, I don't really need to, well, okay. The fact that, before when we were just working with our pseudocode, we might need to have some indication as to whether or not we found a grape, which we now have, which is the fact that coordinate is going to not be null. So we really don't need this anymore. And that's fine. You may, as you're going through stuff, you may have things that you set out to do with your pseudocode that you end up not needing, as well as going, whoops, I think I need something, and adding new stuff in. So stop iterating over the board, right? So we're now going to say that column equals board 0.length and row equals board.length. We'll just pop that above just so that we're explaining what's going on. So now all of our pseudocode has been accounted for. So by doing this, by setting column to board first element dot length, right? So we demanded that column be less than that value. We demanded that row be less than board dot length. So by doing that, I've now forced it that since I found a grape, when I get to the end of this particular iteration, I come back up. My for loop is now going to fail, right? Because column, this guard condition will fail. It's no longer less than board 0.length. So that fails, and then we pop out, and then we're back up here on this loop, and row is no longer less than board.length, so it will fail. We pop out, we return our coordinate, all done. Okay, so in looking over this, it seems like all of the chunks that we had set forward have been implemented. We haven't fully been able to test everything, just kind of how things were built.